The disaster of Hiroshima and Nagasaki was condemning. It was worse. But let us understand the science behind why it got so worse. So the whole idea of nuclear fission and fusion is either you break it or you make it. So let's have a look. When I talk about nuclear fission, the very first thing in my mind which comes is there's a nucleus and there's a neutron which bursts the entire nucleus in two different nuclei. So it was discovered by Otto Hahn and Stresemann. To be very honest, that was not completely true. But any which ways, Otto Hahn and Stresemann in 1939, remember that was a time of beginning of World War II. That was a time when they came up with an idea, and they stated that when heavier nuclei is bombarded with neutron, lighter nuclei formed and energy is released, called nuclear fission. So when a uranium is bombarded with neutron, it splits to give barium and krypton. So it is something like this. We can see the uranium, we can see the nucleus, we can see the two barium and krypton, and 3 more nucleons. Now, the new nuclei of barium and krypton has less mass compared to the original mass. So there is a mass defect. That mass defect is converted into energy, and that energy is nothing but your atom bomb energy, which was worse. Anyway, nuclear fission is used basically for a better use. It is used in nuclear power generator for generating electricity. Okay, this is a nuclear reactor where the sustainable reactions takes place. Now, when I talk about nuclear fusion, lighter nuclei fuses to form heavy nuclei. If fission bomb explodes, fusion implodes. It takes everything inside, becomes an unstable system, and bang! What you have is a greater reaction, 10 times more powerful than your nuclear fission. Now, the fusion is all about combining the nuclei together. The newly formed nuclei have less mass again as compared to the original lighter nuclei, just like the concept of mass defect. And that mass defect is converted to energy. But for doing this, you can't just expect, find this is one nucleon, this is one another nucleon, let's fuse it together. Wow, fusion. It doesn't happen that way. Because these two things, they repel each other with a very high force. To do it, you need a very high temperature. 10 raised to 5 degrees Celsius. 10 raised to 5. 1 lakh degrees Celsius. In your normal language, beta tawe pe sekega. No. So the whole idea is that something has to be done. So, to sustain the fusion, first you start with fission. Well, energy generated in stars and suns and satellites and everything is nothing but your fusion energy. That's what it is. Now, if you talk about fission, this is the bomb which I am showing you. Again, a huge explosion. Wow. And when I say explosion, that means miles and miles of radius. Miles and miles. Again, miles and miles. Yes, perfect. It is. So the point is, when neutron is bombarded on uranium, let's see what exactly happened. Uranium, it has mass number of 235 and atomic number of 92. Now, already it's imbalance. So when neutron comes in, it got more and more imbalance. So it couldn't sustain it. And that is the reason why it got split into barium and krypton. Barium has mass number of 144, krypton of 89. Barium has atomic number of 56, krypton has 36, along with 3 more neutrons. Now, per reaction or per step, you get 200 mega electron volt of energy. That is very well enough. Nuclear fusion, on the other hand, it has some miraculous property. Let's see. Fusion, as I told, it implodes, it goes ahead, it blasts along the miles and miles of radius. But for fusion, what you take is a deuterium, isotope of hydrogen. Okay? Along with deuterium, 1 more deuterium. 2 deuterium fuses to form and give you helium. And the energy released is of 24 mega electron volt. You must be asking, sir, there it is 200, here it is only 24. Why? How come this is more powerful than that? My dear students, that 200 mega electron volt was for 236 nucleons. This 24 mega electron volt is just for 4 nucleons. per nucleon energy release had to be considered, in which fusion ranks ahead of fission. So, let's compare between fission and fusion. First is fission is for heavy elements, fusion is for lighter elements. It takes little energy to split two atoms, but here it takes more energy, 10 raised to 5 degrees Celsius. Energy liberated is very high, 200 MeV. So your energy release is 3-4 times greater than the fission. That's another part. And for that I explained you just now. Per nucleon, consider the binding energy. Fission reaction does not normally occur in nature. Okay? So fusion occurs. Of course, in stars, sun and everything, what you see is a fusion. And the last point, fission is used in nuclear power reactors, whereas fusion is an experimental technology for producing more and more power. Though fission and fusion has their own disadvantage, but if you use it, channelize it for good direction, proper direction, revolution will occur. And that is what in our future, these are the tools to give you a sustainable energy resource. Thank you.
नहीं, देरी करती है।